Hey there, and welcome back. So today, we're going to tackle a type of algebra problem that seems super simple at first glance, two-step inequalities. But, and this is a big but, there's this one sneaky trap that gets almost everybody. Stick with me and you'll learn exactly how to spot it and cruise right past it every single time. Okay, so take a look at these two. At first glance, they look pretty much the same, right? On the left, a classic equation where x is just one single number, but on the right, we have an inequality where x can be a whole bunch of different numbers. And yeah, the way you solve them is almost identical, but that little symbol, that less than sign, that changes one crucial thing we need to be ready for. But here's the really good news. If you know how to solve a basic two-step equation, you're already in great shape. All those skills you've practiced, they apply directly here. We're just adding one new, tiny little rule on top. Seriously, you're like 90% of the way there already. All right, let's jump in with a pretty straightforward one to get our feet wet. 2x plus 5 is less than 15. We're going to do exactly what you'd expect. Get x all by itself. We'll handle the addition first, then the multiplication. Okay, first things first, we want to get rid of that plus 5. So we'll just subtract 5 from both sides. That leaves us with 2x is less than 10. Now we just divide by 2, and we get our answer. X is less than 5. Easy enough, right? This feels exactly like solving a regular old equation. But what happens when a negative number shows up to the party? And this is where we get to the main event, because that last problem was kind of like the warm-up. Now we get to that one hidden trap I was talking about, the one little detail that can make all the difference between getting the right answer and the wrong one. So check this one out. Negative 3x plus 4 is greater than or equal to 16. You see that little minus sign hanging out with the 3x? That's our clue. That one little negative sign is the trigger for the whole trap. Let's walk through it together. All right, this brings us to what is, without a doubt, the most important part of this whole explainer. I like to call it the golden flip rule. And honestly, if you walk away with just one thing today, please make it this. Okay, so just like before, let's get the easy stuff out of the way first. We'll subtract 4 from both sides of the inequality. That leaves us with negative 3x is greater than or equal to 12. And there we go. We've arrived at that critical moment. So here's where we're at. Negative 3x is greater than or equal to 12. Now, your brain is probably screaming, just divide by negative 3. And you're right, but this is exactly where the trap springs. So here is part 1 of our golden rule, and it's the trigger you've got to watch for. If you multiply or divide by a negative number, the keyword there is negative. This whole rule only kicks in when the number you're multiplying or dividing by is negative. And here's the action you have to take. No exceptions. You must flip the inequality symbol. That's it. That is the entire rule. You see that you're dividing by a negative, you immediately flip the sign to face the other way. So let's put that into practice right now. We're dividing both sides by negative 3. And because we're dividing by a negative, we have to flip that greater than or equal to symbol, and it becomes a less than or equal to symbol. And that gives us our correct final answer. X is less than or equal to negative 4. Okay, so you might be thinking, why? Why do we have to do this? Is this just some random, annoying math rule someone made up? And the answer is, nope, not at all. There's actually some really cool, simple logic behind it. Just picture a number line for a second. We all agree 5 is bigger than 2, right? It's further to the right on the number line. Simple truth. But watch what happens when we multiply both of those numbers by negative 1. The 5 becomes negative 5, and the 2 becomes negative 2. Now, which one is bigger? On the number line, negative 2 is way further to the right than negative 5. They literally swapped places in terms of which one is bigger. So to keep the statement true, we have to flip the sign. Negative 5 is now less than negative 2. That's all the flip rule is doing. Okay, let's wrap this up. We're going to quickly recap the key takeaways so this all sticks in your brain and you'll never fall for that trap again. So let's lock it in. First, remember, 99% of the time, you solve these just like you solve a regular equation. Get the variable alone. Second, and this is the big one, the golden rule. If and only if you multiply or divide both sides by a negative number, you have got to flip that sign. And finally, remember why we do it. It's not magic, it's just keeping the math true, because negatives flip everything on the number line. And that's really it. That's the whole secret. You now have the key to solving any two-step inequality they can throw at you. So now that you've got the flip down, the only question left is, what are you going to solve next?